Welcome back. Tonight's notes are going to be on trigonometric ratios. And trigonometric might sound familiar because we've already learned one. But now we're going to learn two more tonight. So trigonometric ratios, which you'll see it shortened to trig ratios quite often. Because trigonometric is obviously a very long word, so we just call it trig ratios. And like I said, we've already talked about one. The one we've already talked about is tangent. Okay, and we know what tangent is. It's a way to find side lengths given an angle. Okay, so now we're just going to add two more. So let's start off with drawing a triangle. And as a reminder, it needs to be a right triangle. Let's just write that in here. It is always going to be a right triangle. And then let's just use this angle for our theta. Now that is the Greek letter theta. And all that means is angle. Okay, it doesn't mean anything else. It's just a place value for the angle. It's kind of the math way to write angle. We call it theta. Okay, so we've already talked about tangent, and we learned tangent as opposite over adjacent. Okay, we learned that one. It's opposite over adjacent. You can always tell it's opposite because if you're at theta, you're going to go across, so it's opposite. So let's write that one down. We're going to write down our tangent ratio, which we've already learned. That's going to be the tangent of theta equals, and we already know this one, it's opposite over adjacent. Okay, opposite over adjacent is going to be tangent. So that's the first one. The other two we haven't learned yet. So let's start with the next one, which is going to be sine ratio. Okay, sine, that's how you pronounce that, is sine. The sine ratio, we're going to write that as sin of theta. That is not pronounced sin theta, that is pronounced sine of theta. And sine is always going to be opposite over hypotenuse. And just to remind you, hypotenuse is across from that right angle. So we can label that all the time. This one's going to be the hypotenuse. And this is across from the right angle. So our sine ratio is opposite. Over hypotenuse. Okay, that's what our sine ratio is. Opposite over the hypotenuse. That's always going to be our sine ratio. And then our third trigonometric ratio is cosine. Cosine ratio, and we write that COS of theta, and you don't say that cos theta, that's cosine theta or cos theta. And your cosine ratio is going to be adjacent over hypotenuse. So it's the adjacent over the hypotenuse. So you'll notice you use all three sides just in different ways for the different ratios. So let's draw each ratio separately. So if we have tangent, and I'm drawing the triangle differently so we can see it in a different way this time, and we have theta here, tangent is going to be opposite over adjacent. That's for tangent. For sine, it's opposite over hypotenuse. Remember that hypotenuse is always across from that right angle, so you can always label it. And then finally, cosine is going to be adjacent over hypotenuse. Okay, and that's how all the ratios look. Now there is kind of like a trick to remember which ones go with what, okay? And it's SOHCAHTOA, and we're going to write this down, okay? If you remember SOHCAHTOA, you'll always remember which ones go with what, okay? So we're going to write SOHCAHTOA, okay? SOHCAHTOA. And what that stands for is sine. The sine is opposite and hypotenuse. Ka is cosine, and that's adjacent and hypotenuse. Toa, tangent, is opposite over adjacent. Okay, and that's just a way to remember which sides go with sine, cosine, and tangent. Sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite adjacent. And I apologize, I forgot to label this page. This is going to be page 31. And we're definitely going to put this on our table of contents. So let's go ahead and flip to our table of contents. Trig ratios, page 31. And I want to do a few examples, so let's flip the page. And let's do a few examples using these ratios. Okay, so let's say we have that triangle. The very first thing you always need to do when you're given something like this is determine which trig ratio you should be using. So you need to identify what pieces you have. Now, I'm going to write SOHCAHTOA up here so I can remind myself which ones go with what. Okay, so looking at this, I have a 52-degree angle. The x is opposite. The 13 is the hypotenuse. So looking at our trig ratios, which trig ratio uses opposite and hypotenuse? Hopefully you said sine. So we're going to use the sine of 52, and that's going to equal opposite, which is x, over hypotenuse, which is 13. And then we solve that just like you did with the trig ratio. I'm going to put this over 1 and cross multiply. That'll be 13 times the sine of 52 equals 1 times x is x. Your teacher may do that a little different. You'll get the same answer if you do it a different way. And I'm going to put that in my calculator. Make sure you're in degree. 13 times the sine of 52. And we get 10.24. Okay. It's the same steps when you're solving as you did for tangent. Now we just have multiple things. So I'm going to have you do 2 examples. Okay, so go ahead and do those 2 examples. The video is going to pause. You're going to put in your answers, and the video is going to continue. And I'm going to go over them. But remember, decide which ratio it is, sine, cosine, or tangent, before you start the problem. Okay, so on example 2, we have a 38-degree angle. This 12 is opposite. The x is adjacent. So going up here, opposite and adjacent, that's going to be tangent. So we're going to have the tangent of 38 equals opposite 12 over adjacent x. We solve by cross multiplying. That'll be x times tangent of 38 equals 12. To get x by itself, we're going to divide by the tangent of 38. That goes away right here, so we get x equals, and we put that directly in our calculator, 12 divided by tangent of 38, 15.36. Okay. And for example 3, we have a 16-degree angle. We know 8 is the hypotenuse because it's across from the right angle. And then x is going to be adjacent because it's right next to that 16. Going up here, which one uses the a and the h, the adjacent and hypotenuse? Cosine. So this is going to be the cosine of 16 equals adjacent x over the hypotenuse, which is 8. Again, we cross multiply, and we get 8 times the cosine of 16 equals x. Let's put that in our calculator. 7.69. All right, thank you for watching.